Okay, this is General Physics, Chapter 8, Homework Set Problem, page 196, number 55. Typically, the problem that students have with this particular one is twofold. First of all, you'll notice when I wrote down the problem here, I converted all my kilometers into meters. And we need to do that so everything is compatible with the universal gravitation constant, big letter G. Also, when you do this sketch here, the radius and how do I know that this 111,000 meters, the problem said it was a radius of orbit. And that's a little bit confusing, but when you do the sketch, you quickly realize that 111,000 meters is way less than the radius of the moon. So unless I'm orbiting through the mantle of the moon, I quickly realize that that has to be an altitude. So the distance that we're going to plug into our equations has to be the radius of the moon plus this given altitude. Okay, so we're asked to find the tangential velocity. We're also asked to find the time period. There's really a number of approaches. Probably the quickest one is we have this velocity of a satellite. So we can just plug and chug into here. Again, what we have to be careful of is what we call D. D is going to be our radius of orbit. That's center to center. So I have to compensate for the radius of the moon plus the altitude in meters. So that gives us tangential velocity. And yeah, I know that's part B, but once I know the velocity, and we know this is uniform circular motion, that's just simply their circumference divided by the time period. Okay, now our velocity is in meters per second, so when we plug in unit compatible into this equation, our time is going to be in seconds. And the problem, I think, asks for minutes. But you can convert seconds to minutes, no problem. Another way we could have attacked this is we had Newton's version of Kepler's third law, and we could solve for this time period. Remember, when we're using G, meters and kilograms, then our time will be in seconds, and you'll have to convert that to to minutes, excuse me. Also remember what we're talking about when we are talking about what R is, okay? And that is both the altitude and the radius added together, so don't forget to do that in your calculations.